Hello guys, welcome to In 5 Minutes. In this presentation we are going to see the XOR as a inverter gate. Question will arise that since we are having NOT gate as an inverter, why to use XOR gate? But if you use a NOT gate to invert the input, you will get a strictly inverted output. Okay, but there are many of the cases in the digital system in which you will be always requiring to use the input as it is, or sometimes the same input is required in the inverted form for the various operations. So you cannot each time replace the NOT gates and short circuit the input as it is. So for that we have XOR as a inverter. So that XOR gate, with the use of a single XOR gate, the input can be treated as it is, or you may invert it with the help of XOR. How this process took place, let us see in this 5-minute session. So what we have here is a 3-bit input, and the input side, this is the input side. So input side I have 3 bits, A, B, C, and let us say that A is equal to 0, B is equal to 1, C is equal to 1. Okay, so how we are using the XOR gates? So I have here XOR 1, XOR 1, XOR 2, XOR 3. So it's having 2 input single output XOR gate, of which one input is given to the data input, that is nothing but ABC, and the second input for each one is connected to plus VCC, or you can call it as logic high level. Strictly one of the input is connected to logic 1. Then what will happen? If you see the output section, the output will be this 0 input for A XOR with 1. So output will be 0 XOR with 1, and the output is 1. Here for B, 1 XOR with 1, the output will be 0. And for C, the same operation will take place, 1 XOR with 1, the output is 0. But that is nothing but the A bar, B bar and the C bar, hence it is called as an inverter. Now suppose you are using the same system, some system is connected here. Okay, so called as a digital system, to which inverter input is required. So what available input is A, B, C, and the input should be connected to the digital system, should be inverted, A bar, B bar and C bar. So in that case we can use this operation. But sometimes the input should be directly connected. So what we can do, we have to simply connect this terminal to ground or logic 0. If we connect this second line, the blue ones, to the ground, then strictly one of the input for each XOR gate is 0, and the input will be treated as it is. Suppose this is 0, so A0, 0 XOR with 0, 0, that is the same bit. For B, 1 XOR with 0, it is 1, so B will be treated as it is. C, same operation, C XOR with 0, that is 1 XOR with 0, 1, then a C connected as it is to the digital system, and with the straight delay of 1 stage of OR gate. So inputs will be fed to the system of this one digital system directly with equal amount of delays in both of the cases, whether to feed in the direct inputs or to feed in the inverted inputs. So use of XOR gate as an inverter is explained here in this 5-minute session. And thank you for watching In 5 Minutes. For more ideas in the videos to use the gates, stay tuned to In 5 Minutes. Thank you very much.